Hi folks, in our last recording we learned about the price elasticity of demand, and we were using it as an exemplar to talk about some basic kinds of things with elasticity. We're going to continue to do a little more work with the price elasticity of demand here, and we'll call this Chapter 6, Part 2. And I'm going to highlight for you how elasticity is actually not a slope. I'm going to try to teach you a little bit about elasticity and its relationship with total revenue. And I'm going to get into a little bit more of the details about how to calculate using a specific convention called the midpoint convention. So there's a little overview of what we're going to do. Okay, let's start out with the actual calculations and try to explain this goofy midpoint convention that your textbook has already introduced. The midpoint convention is really about making sure that direction doesn't matter when we're talking about percentage change. And that's going to seem strange because traditionally it does matter. So normally when you're thinking about percentage change, you're going to use x2 minus x1 over x1 times 100. And this would give you percentage change traditionally. We do not want to use this. Okay, this is not going to work. And the reason that it's not going to work is because economists would like to talk about a range and render the direction meaningless. And you can't do that using this traditional formula. So as an example, you're going to see that if you were to do this, you're going to get a 33% increase for our first one, and in the case of our second one we would have 6 minus 8 over 8, or negative 2 over 8, and of course this would be a 25% change. So you get 33 in one direction and 25 in the other. Economists just find this annoying. They want to talk about 6 to 8 as if it's a range, and they want the answer to come out the same no matter what. Well, what's really changing between these two equations, the way that we've set them up? The overall value on the top is 2 in absolute value. What's changing is the denominators. So if we don't want the overall percentages to change, we need to make sure that the denominators remain the same. So for the midpoint convention, what we're going to do is we are going to do x2 minus x1 over the midpoint of those two. So you can add the two of them together and divide them by 2, or multiply them by a half. So in our case, you're going to be able to take 6 to 8 or 8 to 6, either one, and we are going to divide by 6 plus 8 times a half. So we'll end up with 2 over 7. And it doesn't matter which direction we're going there, we are going to end up with the same exact number. In this case, that's going to be 28.56%. Doesn't matter if you're going from 6 to 8 or 8 to 6, because we're dividing by the midpoint of the two of them in either case. So the reason we call this as a convention is because people just decided this is how they were going to do things. And I'm trying to give you a sense of why, and that has to do with them wanting to talk about it as a range. But whenever you're actually calculating the percentage changes that showed up in our elasticities, I need you to use the midpoint. If the question just gives you the percentages already, you don't need to worry about it. But if you have raw data, I'm going to expect that you use this midpoint convention in your calculations. Okay, let's tackle another oddity of elasticity. Elasticity is absolutely not a slope. It's not an expression of rise over run. It is going to vary across a straight line demand curve unless it's perfectly vertical, which would be perfectly inelastic, or if it's perfectly horizontal, it would be perfectly elastic. But for any sort of quote-unquote normal downward sloping demand curve, you're actually going to end up with a unitary spot or range. You will end up here with the top. It will have an elastic range, And down here towards the bottom, you will end up with an inelastic range. The easiest way to start thinking about why this is the case and why elasticity won't be constant along a straight line demand curve is that when you are up here in the elastic range, any change in prices are actually going to be related to changes in quantities. However, the changes in quantities, percentage-wise, are quite large, whereas the changes in price are relatively small. If you'll remember, our general formula is percentage change in quantity demanded over percentage change in price. Well, in this elastic range here, you've got a very, very big percentage change going on down here with quantity, but you have a relatively small percentage change going on here with price. Of course, if you've got a big numerator and a small denominator, that number is going to be larger than 1. You're going to get an elastic response. Now, alternatively, if you end up lowering the price from 2 to 1, you're going to end up with a very large change in price, but you are going to end up with a very small percentage change in quantity. I hope that's obvious to see now. That's going to produce an inelastic number. Of course, somewhere in the middle, you're going to end up with a tipping point, so you'd have a unit elastic or unitary. But elasticity is not a slope. Keep that straight in your mind. And that's going to also have implications for firms, because if they decide they're going to start to change prices, if they're in a position to do so, it's going to have consequences. There will be a range where they can raise prices and actually generate more money for themselves. And then there's going to be a range where as they continue to raise prices, they're actually going to start losing money. We'll look at that coming up. Okay, so let's continue with that train of thought from the last slide. As a firm raises prices, sometimes they're going to make a little more money. Sometimes they're actually going to lose money. You'd like to have some sort of way to figure out what you should do if you were a firm who actually has control over their prices, or some amount of price-making power. Elasticity provides us a relationship between elasticities and total revenue. So the general rules here are if you are in the elastic region of the demand curve, then you are going to be able to increase your total revenue by dropping your price. If you are in the inelastic region, then you're going to want to increase your price in order to raise your total revenue. And the tipping point, where you're at your maximum, is when total revenue is maxed, I should say, at the unitary spot. The easiest way to start to understand this is to look at it graphically. If in fact you are in the elastic region of the curve and you lower your prices, you are going to go ahead and drop price, and as you drop price, you are going to grab some more quantity. Now, total revenue is nothing more than P times Q. So the area of that blue box compared to the old black box that was there shows you what's happening with revenue. It's going to be obvious that you lost this area. At least I hope it's obvious to you. That part's no longer in the new revenue box, so this is a loss of revenue. But the nice thing about it is that you are going to actually pick up the area here, right? That's new addition. And of course, this is a gain to total revenue. That blue rectangle is larger than the black one, so by lowering prices in the elastic region, you actually were able to gain total revenue. Now the exact opposite is true when you are over here in the inelastic region. If you were to go ahead and decrease your prices here, you would essentially grab on this extra area, but you would lose this area. Of course, the losses here are going to be bigger than the gains. So by lowering your price in the inelastic region, you actually hurt your total revenue. If you're in the inelastic region, you want to go ahead and raise that price. Okay. Hopefully this helps you to keep it all straight. The best spot that you can be at is when your elasticity is equal to 1. If your elasticity is equal to 1, then this will naturally maximize your total revenue. This is useful for firms to know, particularly if they're like a monopoly and they essentially are going to choose where they want to be on a demand curve. All right, so we're going to do something a little different in this little lecture series. I want you to take a look at this problem, and after we get it set up, I want you to go ahead and pause the video and work it out. So if I were to give you a scenario and told you that the price of gasoline was going to go from $1.89 to $2.17, and the quantity demand was going to decrease from 20,000 to 18,000 gallons, I want to know what the elasticity of demand is, the price elasticity of demand. And I want to know what the change is in total revenue, and does this make sense? So calculate the elasticity, then calculate the change in total revenue, and relate it back to those rules that we were just thinking about in the previous slides. Go ahead and hit pause now and work this out. Okay, hopefully you got that worked out. Let's see if you got the right answer. I've organized the information from the last slide in a little demand table here. We need to go ahead and stick these values into our general formula for elasticity. We're also going to eventually take the absolute value of this so that it matches up with the ranges that we learned. So our new Q is 18. Our old Q is 20,000. I'm just dropping the zeros because they'll go away anyways. And we're going to add the two of those together and multiply them by 1/2, which is the same thing as dividing by 2. This is the top part of our equation here. The hundreds are going to cancel out, so I'm going to ignore those for the moment. P2 minus P1, we've got to get this information from our price. Our 18 and 20 came from our QD. So let's go ahead and do our price stuff. New price is $2.17. Old price was $1.89. We're of course going to go ahead and add those together and then multiply them by 1/2. Once you've got all this plugged in, all you've got to do now is calculate the final answer. Oftentimes, if you're working by hand or on a calculator, it's useful to calculate the number in the numerator, write it down, calculate the number in the denominator, write it down, and then divide the two of them. That'll help you keep things straight. Otherwise, students have a tendency to make calculator errors. Once you plugged all these in, you're going to find out that this comes out to a negative 0.76. And if we take the absolute value of that, we're going to find out that ED is equal to 0.76, and this is inelastic. Okay. Hopefully that's the answer that you got. The other piece of this question was what's going on with total revenue. Now total revenue, if you'll recall, is just equal to P times Q. So you've got 20,000 times 189 in our scenario number 1, and then we've got 18,000 times 217 in scenario 2. This is going to work out to be 37,800, and this bottom one is going to work out to be 39,060. So total revenue actually has gone up, which makes perfect sense because if we're in the inelastic region of a curve, increasing the price is supposed to increase total revenue. And that's exactly what we see happening here. Total revenue went up by $1,260. Hopefully that helps in terms of setting stuff up. All you really need for elasticity is practice.